Hey everyone, it's Ms. Seward. Today we're going to be learning about section 3.3, which is on survivorship curves. The learning objective for today is that you'll be able to explain survivorship curves, and our essential knowledge is that you're going to be learning about the three different types of curves there are, type 1, type 2, type 3, and how these relate to the K-selected species and R-selected species that you just learned about in section 3.2. So a survivorship curve, it's going to be something that we're looking at on a graph. It's going to be a line that shows survival rates of a cohort, which is a group of same age individuals in a population from birth to death. Now, one of the things that I want to point out, first of all, with this graph is the fact that it's just compared to the cohort. So when we're looking at age here, this graph is not saying that a dandelion lives the same amount of time as a squirrel and a blue whale, because clearly they all have different lifespans. But we're just saying like the percentage of this cohort, how many of those have been surviving from infancy to the last one of the group who is going to be dying. So just be aware when we're looking at the scales, that's what we're meaning, is how it compares to the entire cohort, not necessarily how a dandelion compares to a whale here. So this is looking at all of the blue whales that were born at the same time, what their survivorship looks like over time, versus all of the dandelions that were born at, they aren't all born, but go out into the world. How many, all of them at the same time, would survive by the end of when the last one died. So when we're looking at these curves, a faster drop-off line is going to mean quicker die-off of individuals. So something like this will be quicker die-off of individuals. A slower drop in the line is going to mean, like slower drop here, is going to tend to mean a longer average lifespan. So when we look at these three different types, again, we have type 1, type 2, and type 3. And you can think of this in the sense of K-selected and R-selected species, because those strategies for reproduction are going to be shown here in these graphs. So if we're looking at type 1, this is mostly going to be our K-selected species. And they have a high survivorship early in life due to high parental care. So if we look at this graph here, we're not having a ton of die-off at the beginning because humans are taking care of those very vulnerable little babies. They also have a higher survivorship in midlife just due to the fact that they have a larger size and defensive behavior. So if you're thinking of like a grizzly bear, they can defend themselves pretty well. So they are less likely to die off in the middle of their years. Now we see a rapid decrease in survivorship in late life, and that's just because of old age. So humans, once you start hitting later in life, there's just going to be natural causes that you're going to be passing away from. So when we're looking at type 1, again, this is mostly our K-selected species, and this is going to count for most mammals. Then we have type 2, and this is kind of our in-between. Remember that we talked about K and R species are on a spectrum, so kind of in the middle. And this might be things like birds, or you could think of rabbits. And this is because they have some parental care, but it's not going to be as intense as many mammals like humans. So what we see here is a steadily decreasing survivorship throughout life. At the beginning, the parents are caring for them, but you think of like a little baby fledgling, it's going to be pretty susceptible to some predators coming in or dying from the cold. So although there is some parental care helping to keep them alive, they aren't as good as staying alive when they're young as many mammals are. And then over time, we're just going to see a continual die-off. Many of these species are not able to defend themselves as well, and so they're not going to have as much success later in life. So it's just going to be a pretty continual decreasing survivorship over time. Type 3, this is going to be mostly our R-selected species. So if you look at this tree here, we're going to see high mortality, low survivorship in early life due to the fact that there's little to no parental care. If you think of a tree giving off its seeds, there's going to be a lot of those seeds that fall on rocks and they don't sprout. They're going to get eaten by birds. They're going to get trampled on and they're going to die. And a lot of those are going to not survive. Now, I want you to keep in mind that it's still a reproductive strategy. Type 3, those R-selected species, they're still succeeding at reproduction because they make so many of them. So even if you have hundreds of them die off, you might still have dozens of them who survived. So it just because they have them dying off when they're young does not mean that it's not a successful species overall over time. So again, back to the graph. Then when we're looking at midlife, few of them make it to midlife. But once they get past this point of all the little babies dying off, then we are going to see kind of a steady decline in survivorship in midlife. And even fewer are going to make it to adulthood. But there is a slower decline in survivorship in old age. Because you think of like a tree, the ones who have made it this far and are established, they are going to be doing all right, but slowly over time, eventually, they will all not exist anymore. So the examples of some of the species that we think of with type 3 here are going to be like insects or fish or plants. And a reminder that when we look at this graph, it is not saying that all of these organisms live to the same amount of time. We are saying that we're kind of looking at like a proportion of, you look at all the ones who were born or created as offspring at the same time, and then we follow that group throughout their whole life. Then that's where we're going to be seeing this time scale. Now your practice FRQ for 3.3 is going to be looking at this graph, and I want you to describe the trend in survivorship shown in this graph. Then I want you to justify which type of survivorship curve these data represent. So that's your FRQ for 3.3, and those were your notes on section 3.3 about survivorship curves.